This short video talks about the possible failure mechanisms that might occur in rolled steel beams. The first is the plastic moment capacity of a beam. This occurs when the beam has fully yielded over its entire cross-section. That is, it has reached yield strength completely from top to bottom. This will be based on a section property that's known as the plastic section modulus. You can look this property up along with other properties in the steel tables. What you should recognize is that the plastic moment capacity of a beam is the highest moment capacity that that beam can achieve. The other type of failure mechanisms that can occur revolve around lateral torsional buckling. The two types of buckling are inelastic lateral torsional buckling, which occurs at higher stresses, and elastic lateral torsional buckling, which occur at lower stresses and basically means that the beam is behaving elastically, that is, able to return to its undeformed state. Lateral torsional buckling occurs because a beam's unbraced length of its compression flange is long enough that this failure mechanism occurs. What happens is if the compression flange is unbraced to the extent that this occurs, the moment capacity of that beam will actually be reduced. That is, the beam cannot achieve plastic moment capacity. As the unbraced length of the compression flange gets longer or more unsupported, the moment capacity of that beam will actually decrease. I usually talk about the failure mechanisms being in categories. Category 1 behavior is the plastic moment capacity. Beams are able to achieve this if their unbraced length of the compression flange, which we will refer to as LB, if this unbraced length is less than some value which we call LP. We'll talk about this value on the next slide. Category 2 is for all beams whose failure mechanism is inelastic lateral torsional buckling. This occurs when the unbraced length of the compression flange for this beam is greater than a value called LP, but less than or equal to another value which we call LR. And category 3 is for all beams whose failure mode is from elastic lateral torsional buckling, and that occurs when the unbraced length of a beam is greater than some value we refer to as LR. LP and LR basically are dividing lines. They are values which we will compare a beam's unbraced length against, and this comparison will tell us which behavior is occurring. You can find the values for LP and LR from the steel manual if you have this available. The steel manual has several tables in it that list, along with many other properties of a steel section, beam section, the values for LP and LR, typically for yield strengths of 50 KSI. If you don't have the steel manual available, then you'll have to calculate it from a formula. These formulas are as shown on this slide. The modulus of elasticity is always taken as 29,000 KSI for structural steel. It should be mentioned that the formula you see there for L sub R, this dividing line, is a conservative formula. There is a much longer formula that's listed in the steel manual that's more difficult to calculate. The actual values for LR in the steel manual are based on this longer formula, but for our purposes the shorter formula is okay. An example of how to calculate LP and LR are as shown here. You can get the values for RY and RTS from the property tables. Modulus of elasticity is always 29,000 KSI. You can plug these values into the appropriate formulas LP for a W12 by 87 as a 50 KSI steel comes out to be a little over 130 inches. If we converted that into feet, it'd be 10.8 feet. L sub R would be a little shy of 313 inches, which would be in feet, expressed in feet, as 26.1 feet.